Solving an equation that's in quadratic form. Sometimes we have equations that are quadratics in disguise, and we use a process of substitution to make it look like something we're more familiar with. What we do is we look at the middle term to give us an idea for what that substitution is going to be. So I'm going to I'll use a dummy variable as of u, which is, u is a common variable that we use for substitution. I'm going to have u be equal to the variable that's in that middle term, which is x squared. So that means that when I have u squared, that's going to be x to the fourth power. So now I can rewrite this whole thing as u to the second power, again that's x squared, minus 8 times u minus 9 is equal to 0. We know how to factor this. This factors into u minus 9 and u plus 1. And then we can split this into two separate equations so that u is either equal to 9 or u is equal to negative 1. We have to go back now to our original variable and substitute it in because our original equation is in terms of x, and what we have written right now is in terms of u. So I'm going to go back to my original substitution and write that x squared is equal to 9 or x squared is equal to negative 1. In both of these cases, I'm going to take the square root of both sides. But when I do the square root, I will end up with x equals, remember I have to do a plus or a minus 3. And x equals, the square root of negative 1 is I, so plus or minus I. So I'm getting 4 answers in this situation. 2 of them are real numbers and 2 of them are complex numbers. Let's look at example B. I'm looking at the term that's in the middle. Well, it's not in the middle yet. Let's start by adding 2 to both sides. We want to have everything equaling 0 before we start the process so that it looks like we have a middle term, which I was just referencing, because we want to choose our variable substitution to be based off that middle term. So in this case, u is going to be equal to t minus 1. And u squared is t minus 1, the quantity squared. So let's rewrite this to be 4 times u squared minus 9 times u plus 2 equals 0. To factor this, we'll look at the first and the last numbers, multiply them together to get 8, and we'll select 1 and 8 as the numbers that we want to combine to get that middle term. The middle term is negative, so both of them need to be negative. So we'll split this into, let's do a minus 8u and minus u. And then we factor by grouping. So I'll factor out a 4u from each of the first ones. I'll have 4u times u minus 2. And then the second one is also going to be u minus 2. So it looks like I would want a negative 1 here to make that work. So 4u minus 1 and u minus 2, this should be a 0, equals 0. Okay. So 4u minus 1 is equal to 0, or u minus 2 is equal to 0. So 4u is equal to 1, u is equal to 1/4, or u is equal to 2. Let's go back and look at what our original variables were. we said that u was equal to t minus 1. So I'm going to make a substitution again here. I'm going to say t minus 1 is equal to 1/4, and t minus 1 is equal to 2. So for this one, I'm going to get that t is equal to 1/4 plus 1 will give me 5/4. And for this one, I'll get t is equal to 3. I need to remember to go back to my original variable and write my final answer in terms of that variable. This is example C. For example C, the middle term is sitting here, and so we know that our variable substitution is going to be x equals, or u equals x to the 1/3 power. So if I square both sides of this, when I have an exponent raised to an exponent, I multiply those numbers together, so that ends up being x to the 2/3 power. So my new equation will be u squared minus 5u plus 6 equals 0. This factors into u minus 2, u minus 3. So u minus 2 equals 0, or u minus 3 equals 0. U is equal to 2, or u is equal to 3. Let's go back and substitute in our original variable there. So that was x to the 1/3 is equal to 2, or x to the 1/3 is equal to 3. To get rid of that 1/3 power, what I'm going to do is I'm going to raise both sides of these equations to the 3rd power. Remember that when I do that, this over here becomes a 1. So then I just have x equals 2 cubed, which is 8, or x equals 3 cubed, which is 27. So these are my two answers. All right, this is an equation that we solved in a previous section by clearing the denominators. We're going to do the same thing again, but this one is actually going to end up being a quadratic. So let's recall what we've done previously. The first thing that we did was we wanted to get rid of the denominators by multiplying by the least common denominator. So we have an x minus 2 as one of our denominators. We have an x as one of our denominators. And then we have x squared minus 2x, which factors into x times x minus 2. So it seems like if we multiply by this, it should cover all of the denominators because it's got these other two sitting here. So we think that this is going to be our LCD. So I'm going to multiply both sides of this by x times x minus 2, x times x minus 2. Okay. On the left-hand side, when I multiply by this first fraction, the x minus 2's are going to cancel each other, and we'll be left with x times 3x plus 2. When I multiply by that next fraction, the x's are going to cancel each other, and I'll be left with just a 1 times x minus 2. All right, let's switch to the other side. On the other side, when I multiply, this whole denominator is going to cancel with this whole thing. And so I'm going to be left with just a minus 2. All right, let's simplify this. we'll have a 3x squared plus 2x plus x minus 2 equals negative 2. Let's collect all the terms together. We'll combine these two together and let's add 2 to both sides. Whenever we have a quadratic, we want everything on one side and 0 on the other. So we have 3x squared plus 3x equals 0. Those 2's are going to cancel. So we'll factor a 3x out. So either 3x equals 0 or x plus 1 equals 0. So x is equal to 0 or x is equal to negative 1. All right, let's check our answers here to see if these are correct. Now, looking back at our original equation up here, I'm going to erase some of this stuff that's on the outside here. We have to think about what are the things that are going to make the denominator equal to 0. Well, one of them is a 2. If I plug 2 in here, I'm going to get 0 in the denominator, which is illegal. So we don't have 2 as one of our answers, but we do have 0 as one of our answers. So it looks like we need to reject 0 because it's not allowed. It's going to make the denominator equal to 0. Negative 1 looks like it might be okay. We should just double check to make sure that it actually works. So let's check x equals negative 1. I'm going to put negative 1 in for x. There's a lot of them here. So 3 times negative 1 plus 2. When I take negative 1 and square it, that's going to end up being a positive number. I'm putting it in parentheses to remind myself to square that. All right, let's double check before we simplify this to make sure that everything is plugged in properly. Everywhere that we had an x in the original, we want to have a negative 1 plugged in. So 3x plus 2, x minus 2, 1 over negative 2. Okay, this looks good. All right, so let's double check. And again, we want to know whether these two sides are equal. So I'm getting negative 3 plus 2 in this numerator. Negative 1 minus 2 is going to be a negative 3. This is going to be, oh, this will change to minus 1. Negative 2 over 1 plus 2. Okay, so I'm getting negative 1 over negative 3 minus 1. That's 1/3 minus 1, or negative 2/3. And it looks like on this other side, I'm also getting negative 2/3. That's excellent. So we're getting that x equals negative 1 is our final answer.